There we go. Got it. Nice. Okay. Alright, hello, hello, hello. Hello. How's everybody today? We got Alright. We'll wait for a few more people to come on in. Hopefully people are starting to come on in. If you do, just pop and say hello. Get started fairly soon here with the lecture stuff. And a couple things we'll need to talk about here. Wait for, we got a couple more minutes here. Yes, indeed, Chase. Good afternoon to you as well. Yes, we will certainly be talking about the exam here today. So we're going to finish up, of course, the last bit of Chapter 2. Yeah, we're going to be going over the last bit here. So if there's going to be certain parts, I'm sure, on Alex that we haven't gone over yet, because we have a few more questions to do, I'm sure. I hope that my email to you answered a little bit of your question, though. I hope it made it a little more clear. All that matters is that you can understand where I was coming from with the answer that I gave you in the email that I sent you. And see if we can expand on that a little bit and make it a little more clear afterwards. Still a little confused? Okay, that's fine. We can do an example or two after we're done, and then we can kind of clear things up there. Looks like a slow roll coming in today. Wait for a few more people to come in, hopefully in a couple minutes or so. Yeah, no problem, Chase, of course. I know for domain and range and things like that, that can be a little confusing. So we can take a look at a couple of examples that can certainly be helpful. Alrighty. Where are we? Right. And done two. Yeah, we just have to do the rest of this. Alright. Should be in good shape nonetheless. Alright. We are in very good shape. Alright. Pretty ahead. Not bad. Not bad at all, I must say. Alright, wait another minute or so and then we'll get started here. Hopefully we get a few more people coming in. I see some people here in the chat. That's good. This is section 2.7 still. Hi, Gerda. Yeah, we won't be doing section 2.8. So, section 2.7 is the last section. So just making sure that at least that's clear about where we're going. Whew, alright. Alright, waited enough time here. Gotta get started. Alright. Okay, let's get started today. Welcome back to Tuesday. Hopefully you have a nice weekend. What are y'all doing for homework on Alex? That'll just be on Unit 1, so the Unit 1 homework there. Alright, so let's talk about today. We're going to finish up section 2.7. Alright, so section 2.7 is the last section here of Unit 1, which will cover the chapters 1 and 2, essentially the sections we did cover in chapters 1 and 2. So we will not be doing section 2.8, okay? That won't be included, but everything else so that we did do, that'll be reflected on the test. We'll talk about the test here at the end of class as well. So a couple things we'll need to discuss, but before we do that, we need to go ahead and take care of the rest of section 2.7. If we have time, we'll start a little bit of chapter 3. All right. So last time we talked about the inverses of functions, and we looked at a way to actually algebraically solve for an inverse of a function. Okay, so we were able to do that to how to find an inverse of a function. Now today we're getting into a little bit more detail in regards to how to say how to look at inverses of functions in other aspects. Okay, so what we're going to do is we're going to start here at question number 2 here today on the handout. Okay, and it asks, how do we know if two functions are inverses of each other? Okay, so this is actually a rule that goes with what we talked about last time in the last section, and that has something to do with the composition of functions. So if we do FOG of x, all right, between those two functions, if they're inverses of each other, then that's equal to x, and GOF of x also must equal x. Okay, so this is the rule. We have to satisfy both conditions here. FOG of x has to somehow magically equal x, and if we reverse stuff around, somehow that magically equals x. All right, then we can say for certain that those are inverses of each other. So let's take a look here at some examples, and let's see if we can determine whether or not a pair of functions are inverses or not. Okay, so let me go to the math type thing. There we go. Okay, so I'm gonna put this. Gonna put our two examples here. So let's set f of x here. Let's have that equal to. We'll go with. We'll go with that 3x plus 8, and we'll go with g of x here, which is going to equal. Let's see. We're gonna go x minus 8 over 3. Okay, so here are our two functions that we have, and we want to test to see if these two functions here specifically are inverses of each other. Okay, so using our definition here, let's at least talk about how we can do that. Now going back here for just a second, again, we're going to make sure we do the composition function, FOG, and do the composition function of GOF. If one of these just fails, you don't have to do the other one. Okay, so if one of these fails, then you would say, no, they're not inverses. But if one of them passes, then yeah, you're going to have to do the other one. Okay, well, let's work with FOG first. All right, so let's go with FOG of x. All right. Now, we did say last time FOG of x is f of g of x, so just as a nice friendly reminder, we're plugging in g of x, i.e. this function, into this x in f of x. So what we're going to get is we're going to get 3 times that big old quantity, x minus 8 over 3, and then plus 8 here. Now, once we do that, as you can see here, the 3's will cancel out, and that just leaves you with x minus 8 plus 8. And then the 8's cancel out, and that just leaves you with x. So going one way for FOG, it works. All right, so we get it to work out just fine, no problem. But now we're going to need to go backwards as well. So again, we have to check both. So if we do GOF of x, again that's g of f of x. Okay, so what does this look like? Let's take a look. Again, we're going to plug in f of x into g of x. So we're going to plug in 3x plus 8. We're going to plug in into this x and g of x. So what we're going to have here is we're going to have, let's put this, 3x plus 8 in parentheses, minus 8. We'll put that over 3. Okay. And that's what g of f of x looks like so far. We're going to, of course, simplify here. So here we have a plus 8 minus 8. So this plus 8 minus 8 will cancel each other out. That leaves us with 3x over 3 and the 3's cancel out, leaving you with x. So are these inverses of each other? Yes, these are inverses of each other now that we've proven that to be the case. Are there any questions about that before we move forward? We'll do another example, but again, type no in the chat if you want me to move on, or if you have a question, feel free to ask. Okay, I'll go ahead and move on. Let's try the... That's correct. So you need to follow both rules. That's right. That's right, Gerda. So if we're to follow both rules, both of these have to be true. You have to do the composition of FOG, and that has to equal x, and then you have to reverse the composition around, and they have to have that equal to x. So they do have to equal the same result, but you'll have to do the composition twice to check to see if that's true. If one of them fails, well, the whole thing fails. In this case, it happened to work out, but that's not a guarantee in all circumstances, of course. No, it has to. Good. That's a good question, Gerda. Specifically x. Okay, so specifically x, it has to equal. Right? It can't be like 3x and 3x. That doesn't work that way. It has to be specifically x. So that's a good question. Just kind of that small little detail, I can see where you're kind of getting hung up on. Okay, cool. Okay, let's try another set of functions. Let's see what we get with that. So let's try this first function here be, let's go with 5x minus 9. Let's go with g of x being equal to, let's go with, okay, so we'll go with x plus 5 over 9. All right, and once again, what's our goal? Our goal here is to see if these are inverses of each other. Okay, so let's start off with FOG. So let's start off with FOG of x. All right, so based on these two functions here, what does FOG of x look like? Okay, great. That's correct. All right, so we're going to replace x plus 5 over 9. We're going to plug that into this x in f of x. So let's see what happens. Get 5 times this big old quantity here, x plus 5 over 9 minus 9. Okay, totally agree with that. Okay, all right, again, what's our goal here? Our goal is to get x here, right? That's our goal. Well, if you take a look at this carefully, does this equal x? Can we simplify this really any further than this that will get it to equal to x? You think? Yeah, probably not, right? So you can try, and it doesn't work out like that last example did. So in this case, this is not equal to x. Okay, you can try and multiply the 5 with the x plus 5 and do common denominators and all that stuff, but that's not going to equal x, which is what we want at the end of the day. So because this is not equal to x, it has automatically failed one of the checks, and therefore it means these two functions here, regardless, are not inverses. Okay. All right, so we just have to take a check here again for each one, and we'll be able to get it. Really, it's not too bad. It's just a lot of checks and balances. But since you know it should equal the same thing of x, no problem. Okay, good stuff. Any questions about that? Okay, very good. All right, let's do the next one here. Cuckoo. All right, so let's go to question number 3 here on the handout. It says, how do we know if a graph of a function has an inverse? Okay, so how do we know a graph of a function has an inverse? All right, so in this particular case, I just want to get rid of that stuff. Get rid of this here. So if you recall what we did here at the beginning of this course is when we talked about functions here, we asked the question, be like, all right, how do we know if a graph is a function? And then all we had to do was be like, all right, we did the vertical line test. And that's how we determined whether or not that was a function. In this case, instead of the vertical line test, you're going to use the horizontal line test, which basically states, draw a horizontal line anywhere on the graph. If it hits 2 or more points on the graph, then the graph does not have an inverse. Okay, so again, very strict about how that works. Okay, but let's go ahead and take a look at some examples here, and we'll just do some very quick examples. Really shouldn't take us that much time, in all honesty. Again, we're talking horizontal lines here this time, by the way. So let's go ahead and see if these are yes or no questions very much. So let's try this. Yes or no, has an inverse or not? It says no. Anybody else? Nope, not. Okay. All right. Very good. That's correct. So we draw a horizontal line. As you see here, we're going to hit 2 or more points. So no, we're not no inverses. All right. Let's try the next one here. All right. How about this? Kind of. Actually, this is poorly drawn because my art skills are pretty terrible. Let's try it this way. All right, let's do it that way. All right. This yes. All right. The answer is yes or no. Function inverse exists or no? I see one for yes. Yes. Okay, so for this one here, Yes? Okay, good, good. So we draw a horizontal line. As we see, we only hit 1 point. So the answer is yes. Let's look at another one. How about this one? How about that? Yes or no? Nope. All right. That I agree with. The answer is no. All right. Definitely not. Again, this would hit 2 or more points. All right, let's try this last one here. How about this? This last one, yes. Got a couple yeses. All right, anybody else? No. You see 3 yeses, 1 no. 3 yeses, 2 nos. 3 to 3. Yes, this is true. The answer to this one here specifically is no. Now the reason why is kind of like what you alluded to there, Gerda. If you have a horizontal line, and I'll draw this in red. If you have a horizontal line here, say that horizontal line goes through all those points in this horizontal part of the graph. This is basically like an infinite amount of points. So that's definitely more than 2 or more. Okay, so even though it doesn't look like it, these are all infinite points. Basically this point, this point, this point, this point, this point, which is way more than 2 at the end of the day. So the answer to this is no for that reason. Are there any questions about that? Oh, okay. So yeah, just a little tricky there. That's why throwing that in is not a bad thing. Okay. Remember to hit F5 if you have lag. So there we go. Okay, let's go to number 4. All right. So number 4 says, what do we have to remember when graphing an inverse function? Okay, so let's talk about what we should do when we graph inverse functions. What do we have to remember here? All right, so what we're going to do here is we're going to take an example here, okay, and we're going to go ahead and map out the regular graph for that function, and then we'll map out the inverse function of that. Okay, so let's go ahead and take a look at what will happen in that case. Alrighty. Okay, so let's try it this way. Alright, let's go with this function here for our example. And I'll write out the key on the sheet here, but first we do need a nice simple example to see how we can expand on this. Okay, so let's go with the simple line, 2x minus 1. Alright, easy numbers, easy life. Alright, No problem. All right, now graphing this guy isn't going to be too difficult. But let's go over what we did in order to graph this guy. Remember, we went over and we said, hey, let's do an XY chart for this. Because I want to see some points, okay? I would just want to see some points, and then once we have enough points, we can put it on a graph and put it all together in a, whatever line, whatever that looks like. Okay, let's pick some random numbers here, right? Okay, you guys tell me. Pick a random number and we'll run with it as long as I can graph it. So crazy numbers are impossible to graph, so by hand. You guys pick the number and I'll just put it in for X. What do you think the easiest number to try here first is going to be? Yeah, I'd agree with that. 0. Okay, I agree with that, JTS. Alright, so if I plug in 0 into this function, what do I get back? Alright, -1. Alright, good. Let's pick another number. You guys pick them, I'll just write them down. One, okay? Pick 1. What do we get when we plug in 1? What's our value for y here if we plug in 1? 1, good. Alright, next number. That's correct. Pick the next number for x. -1, fair enough. If we plug in -1, what do we get? -3. All right, and let's. I'll go ahead and pick up 2 more here. We'll pick 2 and 3, and let's say I put -2, and so -2 is going to net me -5. All right. So not too tough when we talk about this is for our function here, f of x. All right. So if we look at the graph here, let's just take a look at the graph here. So the graph here looks like this. We just put it on a little side graph duder here. We had 0, -1. We have 1, 1 right here. Got -1, -3, so right here. So this graph in general, and you could put 2, 3 as well if you kind of feel like it. I mean, it should be pretty easy to establish what this line is going to look like in some form or capacity. All right. So here's what this line looks like, just like so. So this is the line here for f of x. Okay. Need to make this a bit bigger. Just a second here. Where? Oh, well, I guess that'll have to do for now. I could have sworn that I did this last time. Anyway. Oh, I did actually. Let me make this bigger. Boop. And more space, please. There we go. All right. Okay. Got that so far, so good. All right. Okay, so let's say, for example here, we want to find the inverse graph of this particular function. And you're like saying, whoa, 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 I don't even know what the inverse function is. I haven't done my steps that I did last time. I don't have any idea. Well, actually, you kind of do. And that's really kind of the trick here about how to do inverse functions, even if you don't know what the actual function is. So let's go with f inverse of x, okay? And again, we're going to make a little xy chart. Now, I haven't told you what the inverse function of this guy is going to be, but I'm going to also contend that I don't really care what this function is going to be. It could be the ugliest thing on planet Earth, and I could still find out what this graph is going to behave like, nonetheless. So the trick behind this is, let's go to the Word document here before we do that, because we need to talk about the key here in this particular question. And so the big key here in this case comes down to one thing, and what do we have to remember? And that is, we are going backwards, okay, from the original XY chart. This is very important here. So we're effectively going backwards here from the original XY chart. Now I was saying, whoa, 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 time out. Time out. What the heck does that mean, going backwards? Okay, let's expand on that here. All right, what does it mean to say what do you mean by going backwards? All right, shrink this down for just a second here. Now, if we were to go backwards, let's look at the original function here for just a moment. F of x, okay, goes from x to y. So as I asked you in those questions, I said, hey, give me a number. Okay, we took that number that you suggested, plopped it into the function, and out came some other random number that we put in for y. In a sense, we go from left to right. Plug in a number for x, and we get out y. In effect, for f inverse, we're effectively going backwards from our original XY chart. So let me give you a good example. This time, I'm not going to be so random on what numbers I'm going to choose. Instead, I'm going to go ahead and be very selective. In this case, I'll start off with -1. And if I plug in -1 into this random inverse function, since I'm now going backwards, so I'm not going 0, -1, I'm now going -1, 0. Just like so. So you can see here, we're always going backwards here from our original XY chart. Let's try another number. Well, 1 is still 1, so that doesn't change. How about -3? What do we get for -3? Become the x's in the inverse, and the x's here become the y's. That's right. Okay, so if I plug in -3 in this function, what do I get? -1 is correct. That's right. Nice, JTS. So again, you plug in the -3, and we go backwards, whoop, right back to -1. Let's try 3. What do I get with 3? We get 2. Good. And let's pick -5. And -5 indeed will net us -2. All right, good. Okay, so we now have an XY chart for the inverse function here. Let's go ahead and map that out on our canvas here, and let's see exactly what we're working with. All right, so I'm going to put it on the same exact graph here. This time, though, I'll just mark it in red. So I have -1, 0, put that there. 1, 1, put that there. -3, -1, so right here. And 3, 2, so right about here-ish. Again, not the most accurate thing, but does the job. Okay. All right, and there we go. We have our inverse graph that we can see here again as f inverse x. So that's the nice part, is that you don't have to worry about what the actual inverse function is. You can actually find out its behavior directly from the xy chart. And that's exactly why I like doing the xy chart way, is just like you can physically see the numbers and you can easily use them to do what you need to do. In this case, read them off backwards. Are there any questions about that? Again, you can type no in the chat, or again, if you do have a question, let me know. So this is not an inverse, or is it? Yes. So the line in red would be the graph of the inverse function. That's correct, JTS. So this red line is the graph of the inverse function of f of x. No? Okay. All right. Well, let's go ahead and move on then. If there are no more questions, we'll go ahead and just see what we're working with here. So no problem. All right. Let's see here. Okay. Let's talk about question number 5 here. Question number 5 says, what is the domain and range of an inverse function? What is the domain and range of an inverse function? Okay, so let's talk about how this is going to work. It's fairly simple because we saw in the last example what an inverse graph looks like. So it turns out that domain and range are going to pretty much work one and the same in that same vein. So let's put this here. So the domain of the inverse function here, let's go with, trying to find the right thing here. Oh, right. I want to bring that up. All right. So the domain of the inverse function is going to equal the range of the original function, because everything is backwards. Okay, so with everything kind of being backwards there, that's pretty much how that's going to work out. And then, of course, as you can probably guess already, well, everything's just kind of flipped around here for this. No, please. Oh, not 161 there. So the range of this guy, yes, thank you, is going to equal the domain of our guy here. Okay. Okay, so pretty much everything kind of swaps around. So the domain of the inverse is equal to the range of the original function, and the range of the inverse is equal to the domain of the original function. So if we find the original function, we say, hey, this indeed does have an inverse. Okay, we can actually find out what that's going to be when we talk about domain and range. So let's look at an example here. Regarding domain and range, we'll see exactly how that will work out. So, okay, that's the one I want to do. So let's do an example here. Okay. So Here's our example for this. Oops, sorry. Switch to blue. Okay, so here's our example. Let's say f of x equals the square root of x minus 1. Okay? So what we're going to do first is says, okay, let's find the domain and range of this particular function, and then we can find the domain and range of its subsequent inverse function. All right, let's talk about domain. All right, really quick here, and type this in the chat. What does domain mean? What does domain mean? How far the x coordinates stretch out? All possible x values, okay? Not so much as how far the x coordinates stretch out. Say possible x values. Remember, when we talked about domain is all possible x values are correct, but remember it's all x values that work, right? We want to find out every x value that works. So remember, the key when we talked about domain is finding what values do not work and take those away. Okay. So let's look at this one here. We have the square root of x minus 1. Well, we do have a restriction here regarding square root. Isn't that the same as all possible x values? Yes, I just phrase it in a different way because I want you to kind of think about it in a way where you're looking for the ones that don't work and you keep the ones that do work. So it's like playing an inclusion then exclusion kind of game. So that's kind of like that. I know that seems strange, like why I would say it that way, but that's the reason why. Is just to kind of change that perspective, because I'll be honest, some people have a tough time with domain and range. So if I put it in those terms, it's usually easier to see kind of a black and white argument, at least in that case. All right, so let's look at the square root of x minus 1. Well, let's look at square root. What can we not take the square root of? What has to be true about square roots? It can't be negative, that's right. So what we're forced to have here is we're forced to have x minus 1, because that's correct, JTS. It has to be bigger than or equal to 0. No matter what, right? Because we have to ensure and say, hey, if I plug in a random number and that number's negative, well, that's a no-go for me. I'm not allowed to use complex numbers or whatever, so that's out. I have to only have 0 and above. That's what I get to work with. So add 1 to both sides. And so here we have x is bigger than or equal to 1. Okay, so this is going to be effectively our guy right here. Okay. Now, we want every value from 1 to above. So that's going to be our domain. Our domain is from 1 to infinity. Okay. Again, we're excluding anything below 1 because it can't be negative. All right, seems fair. All right, let's talk about the range. Yes, it can be 0, so that's why I put this as equal to 0 here. So bigger than or equal to 0. So that 1 is included. That's why I put a bracket here next to 1. That has to be, that whatever's underneath this root has to be 0 and above. Could it be 0? Well, the problem with 0, if x was equal to 0, if that's your question there, Problem with that is if you'll have 0 minus 1, and then you'll run into trouble if you do that. That'll be the square root of minus 1, and that's a no-go. Okay, so if you plug in 0, that'd be bad. Okay, so the reason why it's a bracket here is because we say that this was included. So included means less than or equal to or bigger than or equal to. We use the parentheses for, again, less than or bigger than, but they're not included. Are there any other questions about that? Before we move forward, anyway. No? Okay. So let's take a look at the range. Well, what's the range for a square root function? Well, the range here for every square root function, since we can only have positive numbers and positive answers, well, that's going to be our range here is from 0 to infinity. So that's kind of a strange thing about square roots is that we sometimes take the negative result. It's like, okay, but this is one of those cases where we only care about the positive results here as part of our range. So yeah, the ambiguity of square roots, or roots in general. All right, any questions about that so far? That's going to be just the square root of x minus 1. So let's take a look here. Let's find the domain and range of the inverse function. Again, I don't know what the domain and range of the inverse function is, but we can find out. So we can find out from our previous information. So what's the domain of the inverse function here? What's our domain for the inverse function here? Okay, 0 to infinity. Good, that's correct. That's going to be equal to the range of our original. And as you could guess, the range here is going to be 1 to infinity. All right, there you go. Questions about that? No? Okay. Just a second here. There we go. Got it. Okay. Good, good. All right. So that is the last question here from section 2.7, which effectively ends chapter 2. Okay. So, of course, since we are done with the material here for chapters 1 and 2, all right, then, of course, now would be a good time to announce the test. Okay, so the test for this material here. So the test will be due. The test will be due next Tuesday. Okay, at near midnight here. So test will be due then, and also the homework will also be due that day as well. So Unit 1 homework, and I'll change the dates on the website if it's not that way. So Unit 1 homework is due on the 22nd at 11:59 p.m. there. Okay. The test will be kind of its own separate thing, basically. Let me go to the assignments tab here. Yeah, so what I'll be doing is I'll be putting up the practice test at the same time as the regular test, so that way you can practice right away. Each test is always worth 100 points. That's how it always works. Simple as that. All right, so let me get this here. Yeah, it'll be. Hang on a second, folks. Getting my stuff together. This is what I see. So we'll make that open here. Okay. And then we'll have that due at 22nd. Okay. Good stuff. So that's again the test there in that instance. Boop. Oh, oops. Yeah, October wasn't what I wanted there. How sad. I'm not very good at that. Yes, you never saw anything, and me screwing up very badly. Yeah, that never happened. Nobody saw that. Nobody. Yeah. Me? I look handsome and distinguished. Wow. Well, thank you. That's very kind of you to say. Usually I'm not a hit with the ladies, trust me on that. I'm just my regular dude self. I'll edit this too. Is this what I... Yeah, so I'm just going to set these homework due dates to be the 22nd as well. I just want to be sure that you guys can see what I'm doing. That's why I'm being like as transparent as possible and be like, okay, you know what, how are you doing this out? Well, this is basically how I do it, so it's not like it's coming from nowhere. Yeah, the lazy way is the best way. I won't deny that 100,000%. This is true. Truth has never been spoken so well. Oh, okay. No, that's a good question there. That's a good question, Gerda. So, the Unit 1 homework is going to be, yeah, this is Unit 1 and Unit 2. So, Unit 1 is going to be sections 1.1 and 1.5, okay? And Unit 2 here is going to be specifically going to be Chapter 2. So, that'll be sections 2.1 to 2.7. Okay, so that's Unit 2 there. So that's exactly what they cover there, and the first test will cover those particular sections. Okay. I want to make that clear. So it's like, okay, what exactly are we doing here? Be like, okay, bro, let's talk about it. Wait, why am I leaving the site? I don't even understand. That hurts my head. All right. Yeah, let's save that. That's a good idea. And I'll also be, like I said here, there's a practice test here. So you can see the practice test that's put up here. I'm going to go ahead and enable that as well. So I haven't done anything with it. But actually, let me go ahead and show this off to you since you guys are online here in regards to practiced exams. So I'll go ahead and hit the preview button here so you can see what this kind of looks like. Yeah, that's kind of the bad part about Alex. I ain't gonna lie, Gerda. Yeah, it kind of does kind of lump stuff together. So, yeah. Um, Again, I'm just kind of using this here. This is like the second or third time I've used it. So, um, basically, look at the number of topics that you finish, and then that's basically your progress to getting done. That's the best way to monitor progress there. Yeah, there are some drawbacks, I ain't gonna lie. So, I don't blame you in that regard. So basically they'll give you unlimited attempts for the test here. So I'll just start um, and I'll show you what this looks like here. So they tell you how to graph a line, or if you want to skip around a little bit, you know, uh, finding solutions here, okay, or again, what defines a function, yes or no. Right. So when you finish, it's done. Correct. So when you're done with those 49 topics, you're effectively done with those with Unit 1 and Unit 2. Right. That's correct. Yeah, it's not super clear about that. I won't lie. So there's a lot of problems in here. Now, we try and mimic this the test here to 42 problems here, but obviously you don't have to do all of them. But there's going to be a hand-picked problem. There's going to be problems that look like these 42 problems, and I believe there are only 20 of them that will be on the exam. Okay, so that's pretty much how that's going to work in that case. Okay, just be sure you get your formatting correct and all that stuff. Okay, you can see here we talk about the composition, find the domain, that sort of thing. Again, any and all of these questions have a potential of showing up. Hey, what's the domain of this function? Actually, let's do this one. I think this one, because we had questions about the domain here. Let's look at this particular question. Find the domain of this function, the square root of 5 minus x. I remember asking this similar question on an exam, so on a written exam. So let's take a look at this one here. What would be the domain of the square root of 5 minus x? Let's talk about that one there. So I'm going to shrink this down here. So what do you think? What has to be true about the square root again? What has to be true underneath the square root? It cannot be negative. That's right. So if we write this out, right, it definitely needs to be positive. 100% agree. All right, so we got 5 minus x. So we're doing the same thing here, right? 5 minus x has to be bigger than or equal to 0. This absolutely needs to be true. Now, you need to be really careful about this next part. If you're a person that likes reading left to right, then this is the part where you need to be very careful. If you're a person like I like x on the left, maybe you're that kind of person. So you subtract 5 on both sides, and you say, okay, that's fine. Maybe you're just just that way. Well, here we want to solve for x, so we're going to divide by minus 1. But remember, this is an inequality. So because we have this minus 1 we're dividing by, we need to flip this sign. So this suddenly becomes x is less than or equal to positive 5. Negative 5 divided by negative 1. So be very careful about that. Again, if you like doing left to right, like x on the left and numbers on the right for simple inequality, then that's something you'll need to be careful about. So here we get x is less than or equal to 5. So sign flipped because we divided by a negative number. So again, note here, only when you multiply or divide by a negative, yes. Okay. So that's why we get x is less than or equal to 5. So we get here. Now, here's a question for you. All right, here's a question for you. How do we write that in interval notation? How do we write x is less than or equal to 5 in interval notation? Okay. We have, well, I see braces there. I think you need brackets or parentheses. So I agree with negative infinity comma 5, but we need parentheses and brackets. So let's try that again. Five comma infinity. This is let's go back here for just a second. All right, this is less than or equal to 5. What you wrote there, Planet, is bigger than or equal to 5. Okay, negative infinity comma 5. Okay, so this is where you need to be a little careful. Remember, what you need to enter in for your answer here specifically needs to be entered in the proper format. So you put brackets next to infinity. Remember, we never put brackets next to infinity. It will always be parentheses. So the one we want to choose here is this. We want to choose this guy right here. And we want to start with negative infinity, so we can go ahead and pick that. We want to go up to 5, just like so. Okay, now one thing to understand here is that, let me go ahead and hit continue. Now it's not going to tell you, but you can come back to the problem here and you can retry it once again. Okay, so that's perfectly fine. There's also examples and explanations, I think. Yeah, so there's an example here as well. Again, this is strictly made for practice. What grade am I teaching? This is college algebra, my friend. College algebra, Spy. So once you're done with all these questions here, you can go ahead and submit your test. Okay, it'll give you a score. But the nice part about the practice test is you get unlimited tries on the practice test. So if you need as much practice as you need, take as much practice as you need, and then you should be good to go in that regard. Okay. I believe you get kind of one try on the regular test. So again, there's only 20. Bleh, let's try that again. There's only 20 questions on the test, on the actual test itself. So be sure that you can take your time on the questions there. But at least 20 of those 42 will definitely appear on the exam. Okay. Any questions about that? Did I save that? Oh, I didn't. That'd be helpful. There we go. Yeah, it's fine. No? Okay. I wanted to be sure that you guys understood what was going to be happening, at least for the exam. So I wanted to be, again, you have a week from now to finish. So, you have time to do it, at your own pace. So, that'll be okay. And I think, let me just check one more thing here. I have to be a little careful here. So, yeah. Let me check this here. All right, yeah, I have to kind of have to do that here. So, all right, okay. Now there is one more thing I do need to talk about here, so I'm gonna kind of show this off here. So, where is it? It's kind of like the tough part that I kind of have to deal with. All right, so again, oh yeah, we're still meeting Thursday for class, of course. Of course, we're meeting Thursday for class. Naturally, we're still trucking. I don't know why we wouldn't meet for class on Thursday. Now, one thing I do want to talk about here in regards to this first exam is how it will be conducted. All right, so how this will be conducted, basically, it will be conducted via the Respondus monitor. Okay, so basically, this is kind of like the anti cheat thing. So I guess they want me to try. So, all right, now I don't know how many of you have webcams or not. Hopefully most of you have webcams. Do most of you have webcams? Question mark. That's the question. You have a webcam there? Yeah, I have a webcam there. Okay. All right. So a lot of you have webcams of some variety. Okay, maybe on your laptop, or maybe on maybe as a separate webcam like I do, whichever one works. I don't know at the end of the day. But if you do have a webcam here, we are going to be using, say, the webcam. Oh yeah, absolutely, man. We are going to be using the webcam here in order to get. This is basically going to be like It'll do like a webcam check, it'll do a facial detection check. You show your ID or your student photo, and then it'll basically start the test after that point. So it will stop if you decide to. It'll lock up your screen, and then essentially you can't use the internet or something like that. So that way, again, it will be proctored. So will it be on for the whole test? Yes, it will be. So what I'll do is I can look over the videos and stuff and all that jazz. I know. But yeah, that's how each of these tests will go essentially. So you'll just use your webcam and then you can start on how to do that. They'll go through a little tutorial about how to use it to monitor how you're taking the test. And then I'll receive a report after the fact. Again, though, my suggestion is to go ahead. Here's my suggestion, though. My suggestion is for you to, again, try the practice problems first. Do it a few times, get used to them, get used to the formatting and things like that, and then go ahead and try the test after that. Okay? So first, get comfortable with the formatting and everything like that, and then when you feel confident, take the test. Are there any questions about that? I want to be sure that you guys at least understand where we're getting stuff. So yeah, you'll need a webcam to take the test. So they kind of require me. They're like, hey, you need to take the webcam. So I'm like, okay, fine. So this is it open book? I mean, uh, it shouldn't be open book. Essentially, I'll see if you're looking at a book or not. It's kind of obvious to tell on a camera. So again, that's what the practice test is there for. You can write stuff on a separate sheet and you can see how the problems work out, and then you can give the actual test a try there. So can you use scratch paper? Sure, you can use scratch paper. That's fine. I don't mind if you use scratch paper. That's cool with me. Honestly, it shouldn't be too difficult, you know. But yeah, of course. Yeah, you can always use a calculator. Yeah, calculator is always allowed. So calculator is always allowed here for tests. We're gonna absolutely need the calculator for future exams anyway. So yeah, 100%. Again, we'll need the graphing calculator for certain concepts anyway. And I'll be honest with you, it'll be your lifesaver in some of the concepts. So I know a lot of you I know a lot of you kind of get nervous because it's like the first test and stuff. But here's what I would, one thing that I do want to express to you. All right, this is kind of a little bit newish for me for doing the test here on this guy. So if you could offer me some feedback after this first test is done, and we'll see where everything is at. If there's certain things that I'm not liking, then I'll see what I can do about future exams for the remainder of the semester. So your input is very valuable as well. We're going to give this one a try. I think it'll be pretty straightforward, but we'll see exactly how things work out here. I want to see exactly what you guys think. I know a test is never any fun, so I don't expect the fun factor to be great, but you know, what I'm really looking for is like, is it a smooth process? Is it not a smooth process? Kind of your opinion on the matter. That's basically what I'm going to be working with here. So I want to be sure that you guys are taken care of as well. And don't worry, even if this first test doesn't go well, I can always make adjustments to the grading and stuff. So rest assured, you're not going to get screwed over if it doesn't turn out so well. I will make necessary adjustments if I feel that that would be necessary. So I'm not in the habit of just throwing you into the frying pan and then let you suffer the consequences. I'm not that kind of person. I'm not that kind of teacher. So does anybody else have any other questions? No? Okay. Yes. That's a great question, Chase. And the answer is yes. At the end of the semester, um, yeah, it's a cumulative final exam. So yes, everything from what we're going to be learning will have a final exam attached to it. Ah. Are we able to redo the past homework for the final exam? Uh, hmm. When we get closer to the end of the semester, I will think about it. But you should probably do the homework that's due. So, should be keeping pace here at the very least. So we'll see where we're at as we get closer to the end of the semester. I can't really answer that question honestly right now. Um, I want to see exactly where we're at, closer to the end there. Once I decide to make that call, though, JTS, I'll certainly tell you right away, and then you can, and then it shouldn't be a problem. So, anything else from anyone? Any other questions? What day is the test on? The day is not. The day is due is the 22nd, so next Tuesday. So you can take the exam anytime between now and next Tuesday. You just get a shot at it, but again, you have the practice test that you can take as many times as you want. So again, you have to finish the test by the 22nd at midnight, or 11:59 p.m. technically, and you'll need to get it done by then. So I'm not having it on, say, a one particular day. I'm giving you from now until next Tuesday to finish. So I think that's fair because, again, then it's easier for you to actually actually have the have the time to do it here. You know what? Let me make a change there. Go back to that. Let me just check something here. You can show, I think you can show your driver's license for that. So, but I'll take out this. Let me see. Hang on. What does this say? Drive navigation. No, okay. All right, that's what they want you to do. So I'll just take this out. Let me. Hang on a second. All right, let's try that. Okay, making some changes as you guys are telling me, things. Okay, so I took off the student photo. You just have to hold up your driver's license, and I think that'll be good. So if that doesn't work for some reason, then email me right away, and I'll make setting changes. So yeah, I'm willing to work with you there. So just make sure you get the Respondus program there. So anything else from anyone? Oh yeah, I did do that. Yay. Oh, well, I did do that too. Well, what do you know? Okay. Hang on a second, folks. I think I just found something here. Ah, that's a great question, Fidel. All right, I'm actually going to answer that right now for you. Ha ha. That's exactly what I was going to actually talk to you about. Okay, so here's what this test is talking about here. So the test time limit is going to be 4 hours. Okay, so it's going to be 4 hours, and you'll have 2 attempts. So I actually changed this. I think I changed this a little time ago. I think that's why I forgot. Quite a while ago. So yeah, you get two attempts at the test. So you get 4 hour time limit, which should be plenty of time to finish 20 questions. If anybody else has complaints about 4 hours of finishing 20 questions, I don't know what to tell you. So and then you get 2 attempts, and you have to retake it fully. The best score is the one that'll stick. So that's pretty much how that'll work out. So hopefully that helps there. So you have plenty of time. So 4 hours. Yeah, it'll automatically take, yeah. It's always best score. So I made it that way, so it's like, okay, hey, now I know what you're doing there. Okay. I did it so long ago that I think I just totally forgot. So like I must have done this like a month ago. Okay. All right, that's been updated there. Good. All right, any other questions you guys have? I know there's a lot of questions around the first test, so I want to just take it slow here. That's fine. No thanks. No thanks. You don't want to do this test, Planet. I know. I know. I know. I know, buddy. I know. Test time. Never fun time. But I've given you plenty of time, plenty of retakes, and you got the practice test to do. So yeah, there's there's certainly things on the table for you to do, but I think hopefully I've given you enough resources of which to help you. Well, you don't, like I said, you have a full week. Okay, so you don't have to take the exam on the same day as the class, as the same day as work. So you can space it out as you need for the next week. Again, I don't know your personal schedule, so I'm not gonna, I have no idea. I know that people work as well, but that's why I kind of, yeah. 20 questions. Are they monster questions? No, not at all. They're fairly short questions, exactly what you see on the practice test. So they're not intended to take a very long time. Like honestly, it probably will take you like an hour, hour and a half if yeah. So I want to be sure you don't have to take everything on the same day. Okay, you can space it out. You can be like, okay, I take the practice test, one day, and then maybe the next day you actually take the test, and then you're done with that, and then you could spend the rest of the time with the assignments that you haven't finished. Okay, that seems fair. So I'm just trying to give as much flexibility to you guys as possible because I know, with an online environment, it's not so easy to kind of work around. So I totally understand that, and I'm very sympathetic to that. I can only go so far, but this is, I think, is a fair, a fair, uh, a fair way to do things. All right. Yeah, we don't have time to really do that right now, so I am going to hold that for next time. Okay. Yeah, a lot to do next time. So we have sections 3.1 and 3.2 for next time. All right. So that's what we're going to do here. So sections 3.1, 3.2. I wanted to spend a little time on the questions there from Test Buddy. So sections 3.1, 3.2 for next time. Again, just review the material there. You should be okay. Um, I don't think you guys will have too much trouble there. I think it should be, hopefully, you'll do all right. Again, you get 2 attempts, so even if you don't do so hot the first time, that's okay. No, no big deal. All right. If there are no more questions, because I don't know if you have any more questions, But if there are no more questions, I'm actually going to end off here just a little early here for today. I think I've given you a lot of things to think about and a lot of things to do. So I don't want to overwhelm you with new material. We'll do that for Thursday. Okay, so we'll do new material there for Thursday. We have to keep moving regardless. Okay, uh, but new material there for Thursday. But before actually let me ask you this question here for you guys, really quick. Would you like before I start chapter 3 here, maybe take a little time, maybe like an hour, maybe take a little time on doing review questions? Would you like me to do that? Okay. Okay. That's fine. All right. Then since it's pretty clear that people would like to ask me review, cover questions and whatnot, we'll go over some of the questions there on the practice test. We'll talk about them and the concepts there. So we'll go over that, and we'll do some review. I think that's definitely fair. So okay, so all right. So I think you guys, it seems like you guys want to go over a few of those problems, just kind of hopefully shake out some of them from cobwebs. That should be all right. All right. Okay, everybody. I want to thank you very much here. Um, if I start the homework, can I send you a problem if I'm confused? Absolutely. Yes. 100%. Send me the problem, send me a screenshot, and I can help you through that problem. Sure. You guys can contact me on email. That's perfectly fine. Okay, everybody. Thanks again. Okay, everybody have a wonderful afternoon/evening. Okay, and I will see you all on Thursday. We're going to get started right away with doing some of the review there. Okay, thank you very much, Planet. You have a very wonderful rest of your day. Okay, we're going to get started with review there. We're going to go right to doing that, and then yeah, let's feel confident. Okay, we can do this. Okay, we can do this. All right, guys, we will see you later. Have yourself a great one. um Chase, did I answer your question, by the way, really quick? I hope I did. Chase in the building? Oh, have a great day, Fidel. Okay, nothing there. All right. Since I haven't heard back from you, just yeah, just throw me an email and I'll get back to you. All right, everybody, have a wonderful day, and we'll see you later. All right, bye. Oh, looks like let's see. Hang on a second. Oop, almost said bye. Uh, give me a second. So just really quick, just get me a screenshot of the problem and I'll answer it later tonight. So I have a few things I have to set up, like pretty much. I have few things I do have to do, but I will get that answer to you ASAP as soon as you send me a screenshot. Once I get back later tonight, if that's okay. Yeah, grab that there. All right. Okay. Okay. Okay, no problem. Yeah, send me that screenshot and I will email you back later on tonight when I get back. And yeah, I want I did promise you I would look at a problem like that, and I do want to answer that for you to kind of clear up any confusion because obviously now you got the test. So yeah, definitely just send that over. All right, guys, I do have to go. All right, have a great one, everyone. We'll see you later.